Right, okay, this particular tutorial is about the Laeq again. And again, we're going to look at some of the maths that surrounds the rearranging of formula. So the formula I'm writing down at the moment is one that represents an Laeq over a certain time period t. So that could be 1 hour, it could be 8 hours, okay? And what we have here is a particular level, an exposure level for a certain time period t. So an application of this particular formula would be, for example, if we had something that was fixed at the upper action value, which is stipulated at 85 dBA, we have to remember that 85 dBA represents your 8-hour Laeq. Okay? So let's suppose that we've got a machine, and let's suppose that machine generates a level of 91 dBA. So the question arises, if we're operating that machine, how long can we operate that machine for before we reach the legal limit of 85 dBA? Remember, this is 85 dBA spread over 8 hours. Now, in one of my other tutorials that I've done, which is a 3 dB tutorial, you will learn already that you can probably guess at what time that this person can spend at 91 before you reach 85. Because simply by going from 85 to 88 to 91, it means that each time that you increase the level by 3 dB, you can halve the time. So this would be for 4 hours, and that therefore would be for 2 hours. So we therefore know, simply by using a rule of thumb, that time should be 2 hours. Sometimes though, we're not given a level so convenient as that, okay? We might have a level that sits somewhere like 92, 93. There again, we can guess that between 91 and 94, we know we'll get another hour reduction on that, so it'll be 1 hour. We know it's going to be somewhere between the 1 and 2 hour mark then. But let's just go with this figure here for this particular issue, okay, and see what time that we can do this. So in this particular formula here, we need to rearrange this formula for little t, which is this parameter here. So putting the figure in here for your Laeq, which is set at 85, we end up with 10 log, and then we have 10 to the L over 10. In this particular case, the L is 91, so that becomes 9.1, times little t, which is what we want to find, all divided by 8 hours. So the problem, therefore, is finding this t. As with the other tutorials, we need to isolate the log term. So take the 10 across, it becomes 8.5 on this side. So I'm going to work my way across here. So we've got 8.5 equals the log of all this stuff in the bracket here, which I'll just leave blank. Then we have to anti-log both sides again. So this becomes 10 to the power of 8.5. And as before, anti-logging a log term is just the term that's in the bracket that remains, which is 10 to the 9.1 times t divided by 8. Okay, and using again the simple rules of manipulating these formulas, keep the t fixed at the top, don't budge that. Take the 8 across to the side, becomes 8 times 10 to the 8.5. 10 to 9.1 here is multiple. Bring it down the other side, it becomes divisible. Okay, and if you key all the numbers in there, okay, magically you will get 2 hours as your time. Okay, so that's the way in which you would work that out. Okay, so the important thing here really is establishing what you want to find. Okay, so this is a typical problem in terms of having a legal limit, a level that you've been exposed to, and you want to know how long you can spend that in that environment. So it's a fairly straightforward calculation, and it always follows that path. Okay, that concludes that tutorial.